So welcome you all. In this video, we are going to see about variable resistance transducer. So as an introduction, so transducers based on the principle of variation in resistance are generally termed as resistance transducer. So from this line, we can able to understand that variation in resistance, that is change of resistance, causes some change in the electrical property. So that is what been called as variation in resistance. So most of the variables like displacement, acceleration, force, temperature, vibration, pressure are transduced using this kind of transducer. So for example, if a particle is being displaced from one place to another, this will cause some changes in the resistance, and because of this electrical property changes. So we could able to measure the change in the displacement or acceleration or force or temperature. So these are generally called as variable resistance transducer. So if you see some of the examples of resistance transducer, change in temperature causes variation of resistance in a copper wire, and this effect could be used to convert temperature into electrical output. So this is what we could able to see in various practical applications, that is temperature into electrical output. So this is the basic formula we all know about the resistance, right? So R is equal to rho L by A, where R is the resistance and rho is the permittivity of the material in ohm meter, and of course L is the length of the wire, and A is the area in meter square. So with the help of this applications, we can able to see potentiometer, resistance temperature detector, then strain gauge, thermistors, and anemometer. So these are the things we are using in our day-to-day life. So strain gauge or resistance temperature detector or thermometer and thermistor, then anemometer. So these are the things we are daily using. So in this specifically, we are going to take only one application, that is a potentiometer. So we all know what is a potentiometer. So basically potentiometer is a simple resistive sensor, uses the theory of resistivity. So change in the resistivity. So if you take the potentiometer, the word change in resistivity is very important. So resistivity is electrical resistance measured for any material having uniform cross-sectional area. So the resistance of a material depends on the following factors. So generally resistance in the sense some opposing force or something we can say. So it depends upon the length or cross-sectional area, resistivity, temperature, or composition. So basically there are two types of this potentiometer. One is the linear or sliding potentiometer. So the so from this diagram you could able to see that there is an resistivity strip over here, and there is a movable wiper setup over here. So if we just move the wiper over the left side or right side, accordingly the resistivity, there is a resistive strip over there in the bottom, so accordingly the resistivity changes. So this depending upon the movement of this wiper, so we can able to find out the displacement, how far it is been moved from the initial position. So because by finding this, we can able to find out the electrical property. So this is the actual view of this linear potentiometer, what we used to see in our laboratory. So mainly engineering students, we might have seen about this variable potentiometer. And the next common type of potentiometer is the angular or rotatory potentiometer. So the disadvantage of this linear potentiometer is that we need a larger area, or the size of this potentiometer is very large. So we could normally it will be of some 1 feet, that is nearly 30 centimeter or more. So that is very difficult. So if you take the linear or angular or rotatory potentiometer, it is a small device. So this is what generally we uses in our laboratory. or in our labs. So we have the strip, a rotating strip over here, so that the space occupied by this potentiometer is very very low. So it will be of few centimeters. As the name suggests, this type of potentiometer has a wiper which can be rotated across the two terminals to vary the resistance of the potentiometer. So we have a carbon strip over here and a wiper is placed over here. So we have to move this wiper to the left side or right side, and accordingly over the carbon strip. So accordingly the resistance changes. So this is what there is angular or rotatory potentiometer is. What normally we used to do it in our laboratory for various experiments. So this is the potentiometer. So dual gang potentiometer. This is concentric potentiometer, and this is the multi-turn potentiometer, which is a common one. So these potentiometer only normally we are using. So I hope you could have gained some basic knowledge about this potentiometer. Thank you.